Hey, good morning everyone. Good morning. My name is Yuri and let's get started. Good morning everyone. Let me know if you can hear me well, see me well, and let's get going. Happy holidays to everyone. Happy New Year, Merry Christmas, Merry Orthodox Christmas, Merry all the Christmases. Good morning everyone. Good morning. Close myself. I know there's delay, so I'll spend this minute while you respond to me with drinking something. It's been a long time, haven't seen you this year. Nice to see you, everybody. Доброго ранку, hyvää huomenta. Those who may concern. All right. Well, someone just say that you can hear me or see me, because I'm kind of worried about that. It's been a long time since I streamed last time. How have been your holidays? Oh, thank you. I'm good. What about you? So today I wanted to do like kind of a simple stream. Well, I'm always trying to do simple streams, but you never know how it turns out. So today I wanted to do a simple three.js stream involved with a little bit of math, and yeah, I hope it's gonna be beautiful, but still it's quite a simple concept. It's not from the website, it's just the thing that I've seen somewhere, and then I tried to replicate it myself and it turned out pretty, and I thought I'd share it with you just to kick off this year. Finally, thank you, Bryce Zenith. Thank you. And thank you for your support throughout the last year. All right, so let's get started. So today I'm going to be using the canvas sketch, and I'm going to kick it off by just running it. And again, lots of people asking me about three.js template. Well, this is three.js template. Oh, all right. That's good. Okay, I'm gonna create the folder. I'm gonna call it Hyper. Well, not just because I like how Hyper sounds, but because the thing we're gonna be making today kind of related to everything hyper. Hyperbolic something. Okay, and then we should just start the template. And let's do that. It's easy as that. It just creates a three.js boilerplate and then runs it in the browser, so you immediately see the result. That's why I like it. Yeah, I'm pleased to see you, everybody, too. Well, lots of people came to this stream. Thank you guys for your support for the last year. So today it's gonna be something simple, and well, I don't know if that's simple, but still, let's try to do it. So this is a sphere. I don't know if you like it or not, but it's a sphere, and it's a red one. So I was inspired by one of the real cool guys. It's J. Miguel Medina. He doesn't have a lot of followers, which is surprising to me because he does an amazing stuff. I'm not really sure what he's using for that. I think it should be Blender or something like that, some kind of that, because the rendering looks amazing. So he does all those weird kind of stuff, and I've seen this animation which I really dig. And then this one is called Hyperbolic Helicoid, and this is actually a famous parametric surface. And I was going to like, maybe I should try to build something beautiful with Hyperbolic Helicoid. And if you're following me on Instagram, I recently just posted an infinite loop which was using this exactly parametric surface, and I think this one is kind of related to the Hyperbolic Helicoid as well, but not quite. Those are just usual sines and cosines. So let's see what this Hyperbolic Helicoid is all about, and how can you use it in three.js, and how you can have your own Hyperbolic Helicoid with just JavaScript. Well, hi, Chuck Norris. All right. So this is a hyperbolic helicoid. If you just Google this keyword, and well, don't get me wrong, maybe one of the reasons that I chose this particular surface is the name of this surface, because, you know, it sounds really cool. It's hyperbolic helicoid. Like, okay. Even though I have a math education, it still sounds pretty cool to me. So I believe you can use this one as an opener even to the math graduate girls or boys. You know, just coming to them and asking them a question about hyperbolic helicoid. All right, so this is a formula for the hyperbolic helicoid. There are lots of other weird kind of stuff that you can dig here, but those the formulas that you don't really need. Usually the ones that you need to build the surface in a 3D space is x, y, z coordinates, which are parameterized with, well, usually 2 or 3 parameters. And usually, well, this is a common thing, they are called u and v. So you could see those v and u here, and you can also see the tau, which is the torsion in this case. And well, we'll see pretty soon what's that. So let's get started. First of all, I'm gonna change my sphere. I'm gonna change the layout. Yeah, greetings everyone. All right, so first of all, I'm gonna create the material. Happy to have you here. All right, so I have this hyperbolic thing. Yeah, it's right here. I'm gonna switch it to the right part of the screen. Wrong one. Whoa, for a year. That's a lot, man. Well, I really appreciate everyone supporting me on Patreon, even though, like, sometimes I miss a Sunday and I feel guilty because of you guys, because you supported me and I then failed you. And I only had like 44 Sundays last year out of 52. Yeah. Well, 3 years ago I had 52 Sundays out of 52, so I didn't miss any Sunday during the year. That was crazy. All right, so we need to create some kind of material. So instead of this boring material, default one, I'm gonna create a new one. Of constant material. Mesh physical material, and then, well, there are a lot of properties that you can set to the mesh physical material. Well, let's see them, by the way. Just go there, you can play with the settings, you can just scroll here, and there's physical material properties like the reflectivity, which doesn't do much at the moment because we don't have any environmental map, I believe. Action, you can change a lot of things here, clear code, roughness, so you could do like a real different kind of looks with this material. And this is the most complicated material in three.js, like with the biggest shader, I think, with the biggest number of properties. So I'm gonna just go ahead with creating a white one, and then I think I'll set the roughness to 0 because, yeah, I want it to be kind of glaring. And then not to be as much like that, I'm gonna add a metallic 0.5. So just creating something beautiful. I think clear code. Yeah, I think I like it when it's big. You could, of course, Google like the real physical part of those parameters, because all of those are properties of the materials. Like the glass is more, I don't know, metallic, reflective, and then some other things like the ground are because just rough, they are not metallic at all, and well, kind of like that. This is a clear-cut roughness, which I think like 0.4 is the best thing to do. This is just about making things a little bit more beautiful than they were before. So right now we don't see anything. That's because we don't have any light in our scene. Yeah, it's metal, it's not metallic. Yeah, you're right. Yep. Hi everyone. All right, so next thing I need to add some lighting here. So I'm gonna just do scene, add ambient light, and then so now we see our sphere because it's finally lighted. Then I think I would also need to add another light, directional light, just to see all those reflections on my object. Yes, that pretty much explains it all. We're just doing the hyperbolic helicoid. Easy as that. 3, which is directional light. And then I need to set the colors, and I think the white is like the most obvious and the best thing to do here. And then I would just position it a bit at the angle. I think let it just be on the y plane, like where y is 0, and just diagonally looking at my object. I need to add this object, scene, add light. Yeah, I see it now. I think I should look at the scene from the other direction. Yeah, kind of like that. So, well, it's really basic stuff. We just created a sphere, which is, well, looking good, even though it's white. So let's continue. By the way, most of the time you should really prefer not sphere geometry, but just icosahedron buffer geometry. It's gonna be just the same. But it's a little bit better because if you do the wireframe true, it looks beautiful. But if you do this same thing with the, come on, so you have these like points where it might be not that beautiful. So it's usually more preferable for all the kinds of animation to use icosahedron. All right, so I have this beautiful icosahedron. I think it looks even better when it's wireframed and not just something else, not just the usual coloring. So let's continue. Next step, we should really create that helicoid. So for this, three.js has a parametric geometry object, and it should be supplied with the function. So we just create the geometry with a new parametric geometry, and there should be some function and then 2 values, like how detailed is that parametric geometry. Oh yeah, yeah, I think it's 1L, right? Yep, thank you guys for spotting this mistake so early. Well, yeah, it looks a bit more metallic, I guess, now. More metal. Is this a subdivision of icosahedron? I don't think so. This is just like something sort of triangulating a sphere, because icosahedron has a lot of let's see. Icosahedron had just the detail parameter, so it's kind of, yeah. So this is the first iteration, detail 0, then the second one. So it's not just subdivision, because subdivision would just leave all those faces flat as they were, but this is kind of more detailed icosahedron. Yeah, what exactly is icosahedron, by the way? I never really asked myself. Okay, if I just Google. So I guess icosahedron is this exact shape, but all of those are kind of look like icosahedron, so that's why they chose the name icosahedron geometry, because they look like icosahedron, but just a little bit different. Okay. Happy New Year, everybody. Hey, Anthony. All right, so we need to create this geometry. Let's do that. Let's do that. So instead of creating the boring usual geometry, create parametric geometry and then call it helicoid. Let's let it stay 2525, and then I need a function. And I think that function should actually bear 3 parameters, like UV and target. And target, which is going to be the thing that we're going to be setting. It's a vector 3 already. So we could U and V are between 0 and 1. Well, the usual kind of stuff. UV, they're usually between 0 and 1. So I can create the simplest parametric surface here. And well, the simplest is going to be just plane. So let's create the plane first. X equals U. Y equals V, Z equals V, and Y equals 0. And then I should just set target, set X, Y, Z. And this should produce me something. Yeah, geometry. Yeah, we have the plane now. I think I should also do the... So we have the simplest plane, which is just built as a parametric surface. And we could, well, go a lot further with that. We could build our own sphere with this parametric Parametric geometry, yeah. So we could just do the math by... Well, I do remember the parameterization of a sphere. It's actually quite easy to remember. So it's going to be between... I don't remember the boundaries. Oh, next second, I don't remember anything. Okay, so I'll get 2 parameters, two angles between 0 and 2 pi's. This multiplied by U. This multiplied by V. And then I could do the math sine U multiplied by sine U, then do the same here, the same but different, and then I should do the cosine of U, and this should be it. Yeah, this should be something like a sphere. Oh, well, of course, yeah, it should be those alphas that I just did. Yeah, so we kind of have a sphere now, which we just did at the helicoid. So it's not really, it's a helicoid sphere, believe it or not. So now we should get back to those parameters actually. So we have a way in three.js to build any kind of shape just by, well, having this. So, well, for instance, I can just multiply this by 4 and we would get something weird. Something really weird. Or maybe divide it by 4. And then we'll get, I don't know, this is a pillow, I think. We just created a pillow. A weird pillow, but, well, a morning pillow, I guess. Yeah, well, sometimes I do use it. I have the format option here. Well, yeah, we just formatted everything. But well, usually when I type, I don't really care about that. Maybe I do it between the commits or something. A reference website? No, it's not reference website. I'm just trying to build a nice thing out of the hyperbolic helicoid this time. So right, we have this, and let's just use the formula for the hyperbolic helicoid. So if you look closer, we have this formula, but it's not just sine. I mean, this is sine h. I don't even know how you read it in English. This is the sine h of sin. No idea, but this is not the usual sine, and if you Google that, this is actually a hyperbolic function. So this is a hyperbolic sine and hyperbolic cosine. So yeah, it's actually sin and then cos. Okay, let's just not read that. So in this sine is actually this formula. So it's not the usual, it's not actually sine. This is something built out of the exponential function. And good thing we don't need to actually build it ourselves, because we actually have it like mass, believe it or not, it's already implemented in JavaScript. So we already have the scene here. Finish, yes, Hiva Hulmenter. So we actually already have this sine function, and it looks weird but beautiful. I mean, it's like this. So they say it's not built in a circle, just like the usual trigonometric function, but it's built in hyperbola, yeah, rather than the circle. All right, so let's implement that. Let's take the formula from the Wolfram and then implement it. So instead of we'll leave alpha and theta the same. So the x, and I think the bottom part is the same in each of the cases. It's 1 plus cos u plus cos v. Yeah, so first calculate the bottom. And then, well, alpha multiplied by, yeah, and now we could calculate xyz, and xyz is going to be math, which is v. Well, let be v is going to be the first one, multiplied by usual sign, and we should also have this torsion field. So t equals, let's say, the 0.5. No, I mean, I think it should be big, something like 5. Right. So multiplied by the usual cosine of t multiplied with theta, and then this whole thing divided by the bottom. Just copy paste it. So for the second part, it's going to be the same, but it's just the sign. And for the last part, it's going to be, both of them is going to be hyperbolic. All right. And both of them just two angles. So it's hyperbolic sine, hyperbolic cosine, and then divided by bottom, I think. Yeah, this should do the job. So it's pretty simple, like if you look at it, right? We didn't do much coding, but we already have something, and this is it's looking like a flower or something. And I think we just need one of the parameters to go into the negative space. So instead of just doing this, maybe I should do sort of this thing. So now we have it symmetric. Now I think this 25 thing is actually how many like the detalization of the loop that we do here for the UVs, how many times we run this helicoid function. I guess I just do something real big. I think that's too big, but now it's starting to look beautiful. I think also the second parameter should also go below 0. And well, maybe it's too much. Getting somewhere. Made a mistake somewhere, but I'm not really sure where. So this is alpha, this is theta. I think I missed something. Shouldn't that be... well, I think the order doesn't really matter here. Oh, the Z, it's gonna be... Yeah, I think you're right. This is a really cool thing, because even though we actually just made a mistake, we just produced another kind of shape, which was actually, well, let's see for a second, our mistake, which was actually kind of interesting in itself. It's like it has two spirals and they are both looking weirdly beautiful. Okay, so I'll continue. Okay, this is going to be sine and this should be cosine. And then once you get this kind of surface, you could actually like play with it. Like I could multiply this one by 2 and I'll get this kind of thing. Maybe I should just do this. Okay, this is the wrong thing to multiply, I think. What I wanted to show you is more like this. Yeah, we could just do it a lot longer than it was. And if we just cut it in half, I think, again, just do only the part, we would get something like natural looking, some kind of beautiful thing looking like nature. But all right, so let's continue. So we have this formula. I think if I just change the E and Y, I would fix my camera immediately. Yeah. And then to this. So it's just so we'll look from the right angle at the surface. Like I think this angle is the best one. So now we have this surface. I could actually multiply this. Not this, still not this, it should be Y. Yeah, so now it looks beautiful. Yep. Well, thank you. All right. Thank you for helping me to fix this mistake. All right, so now we get into the beautiful shape. What I wanted to do next, like, okay, we have a nice geometry, but what if I wanted to color it in the best way? Of course, I could change the coloring inside the inside my material. So I could do sort of this thing. It's going to change the color, but it's not really cool. Like it's still a solid color, even though we have those light spots, but it's still a solid color. So I thought to myself that I really want to implement something weird with the shading, but then I want to preserve my natural looking kind of stuff, like a physical based material. There's a way to do that, and for that we would need to overwrite the default materials, and it's a bit complicated part. Let's do this. So instead of just using material, I'm gonna do a function get material. Inside that function, I'm gonna run this material, I'm gonna return material, and then I want to update this material in some way inside this function. So that's already nice things, like this material has the on before compile thing. Yeah, well, it's so nice that Visual Studio Code actually helps me with that. And this is a function. Well, this is event, just the way it says to you, and it gets the shader. Now, instead of default material. I could already use this one. Where did I have it? Material, okay. That was the last. Okay, I just deleted it, so there's no material set anymore. Okay, so it's working good so far. We already have the material coming from this function. Yeah, mesh normal material would look fine too. Well, we could just try that for a second. Because we have a live, so we could make it interactive. Well, and of course you need to do this. Boring. Yes, it looks kind of beautiful, but the colors are fixed, and I wanted to implement some beautiful palette from the Nihokiles. And let's try to do that. All right, so we have this event now. I should see something on my console, probably. Material on before compile, and I'm running this function. And I think it should be outputting something. Why it doesn't output anything? Like, oh yeah, because I just overrided the material. Oh yeah, now it will output. So it does output me the actual material part, like a shader part from my material, and we have the vertex shader here, and also have the uniforms and the fragment shader. So I'm gonna just extend my material. So I'm gonna do shader uniforms playhead, because I usually have a playhead, and uniforms look like that usually, just some value. Okay, so now we have the playhead part. I could also actually rotate this thing, by the way. If I just rotate this mesh, just so you have something to look at. And then I need to have it here. Yeah, so if you just rotate something built with an exponential things, well, you would get, it's hard to distinguish between the rotation and the actual moving of the object or zooming into the object. So that's what you get. It's kind of, well, the human eye doesn't really see it rotating. It sees it like growing from bottom to top. And this is a beautiful thing about it. And if it was a perfect spiral, you wouldn't, like, you couldn't guess if it's being rotated or zoomed in. And the same thing goes in here. So if you just rotate it, it's already beautiful. But I wanted to make it even more beautiful. So for that, I will override the materials. All right. So we have this on before compile, and then I could actually try to override the material. So I could do the shader fragment shader, and then I could reset it with just shader fragment shader replace. And then, well, what I will be replacing, it's a really big shader, and you can replace different parts of the shader. I already know the part that I need to replace, so I'm gonna just write that down. There are a couple of includes in this shader, so I could just go to the three.js repo. Oh, that's not this. Just go into the source, renderers, shader. I think it's here, physical. It's a pretty big shader, complicated, and I think I need the log depth. Yeah, this part where the color is being calculated, and after that all the like lighting is being applied and all those sort of things. So I'm gonna replace this part make it a new line. I'm gonna replace this part with something and then plus that part. Maybe I should just first do this part and then do this. And this should be a multi-line. So let's just check if this works at all. So we are replacing this part with an empty string plus the same part. So it shouldn't actually do anything. Yeah, it's still working all right. I don't have any errors here. Fine. So now there is a diffuse color RGB, and I could try to override it. Yeah, so we had the right location. So I just replaced this part in a physical based material with my own color. So then I could just implement something weird. Well, first of all, I'm gonna just override the lighting. I'm gonna do not let float diff equals dot product between and then the actual normal. But the normal I think should be v normal in the fragment shader, right? Do we have this v normal thing? And then I could just set the diffuser here. Yeah, so it's kind of a weird lighting that I just implemented, like a real simplified lighting. It is a hack, but there's no other way to do that at the moment. Actually, there is a way to set three.js materials like the node way. It's a different way, but it gets really complicated if you would like to have a nice material. You end up using a lot of code. All right, so now we have the diffusion color, and then I could just go to the IQ palettes. And well, it's hard to estimate the part that Nicolas plays in the graphics world. So I think I like which one? I like this one. Boom, boom, boom. So we're gonna have this, and this. And then it should be A, B, C, D. And then the actual formula is this. It's going to be A plus B multiplied by cosine. And then C multiplied by T, and T is going to be the diffusion I just calculated. And 2 pi's multiplied by 3, divided by this, divided by this. I think this is it, everything correct. I just converted the formula to the GLSL. So now instead of using this thing, I could just override it with my color. And it starts to look beautiful, I should say. Still a couple of things missing, but I think I would also like to override this shader with the to add my uniform playhead. I don't really need, I mean, not only I need to add it here, I think I need to sort of this thing, and then plot playhead, uniform float playhead. Right. So we just added the playhead, and now we should be able to use this playhead here, and I would just add it here, plus playhead. Doesn't do anything yet, by the way, because why? What's the reason? Invalid character. Should I maybe just add line break there? No? Line 78, let's see the 78th line. So I think it should be just about the line break here. Oh, it's not the right place. I should have line break here. So it's just I couldn't have anything on the same line with the defines in my shader. That's why it was throwing an error here. Alrighty, getting there. So we're not really updating the actual shader, and I think if I just try to do this inside my material uniforms playhead, do I have it? Not read property. I think I need to do something like this. I need to set the for my material, so it's going to be material user data, which is usually an object that you use to, you know, store some data, and then I'm going to store my whole shader, which has the uniforms, in here. And this means that now I'm gonna have the material. Where I have it, user data uniforms playhead. I think it's like this. Still okay. So let's see what's inside the user data now. We have the shader, and shader has we have the shader uniforms playhead. Okay, it's not uniforms. It's something else, and let's just see what's inside there. Let's not guess. Well, I have the uniforms here. Oh, that's because, okay, I think I need to check. It's all right now. Yeah, we're getting there. So now I could just set this thing. It's value. I keep forgetting about that. So now I think it should be traveling, but maybe I should multiply it by 3. Yeah, now it's going all over the places with those colors. Yeah, they are resolved by three.js core part. Okay, so I also wanted to add 2 more things in here. Well, first of all, I think shadows would be nice, and to do shadows I need to set a lot of things. I actually need to set the light test shadow true. And then I should set the mesh true as well. And then I should set the shading on the renderer also. Like let's enable it true. and then the soft shadow map. So it's gonna be shadow map type. Soft shadow map. Well, that's my hobby, and then my work, well, because my work is my hobby, so it's everything, both of them. So now we have it. We should actually have render rare. We're getting there, but I need to set something for my light, the shadow to look beautiful. And I think, if I remember properly, the parameters that look better, those are we could actually set the quality of the shadow, map size with B2K, and then we could also set the size of the whole box of the light, and it makes the light more detailed. And for that, right is gonna be 2, means left is gonna be -2, and then the top should be 2, and then the bottom -2. So now we kind of get the light, not yet, I think maybe the light bias. But we kind of have this shadow here, but I wonder why it doesn't look that great at the moment. So we can get this. I'm wondering if the bias is changing anything. All right, getting there. So now we have this shape. I think right now you could see the detailization part, and we could, well, make it a lot more detailed, of course. But the last thing I wanted to do here, wonder why it's not that bright at the moment as well. It would be much brighter than that. I mean, the shadows should be much better. Maybe lower the ambient. And then what am I missing here? Well, whatever, let's try to add some balls first. I wanted to add the balls. I'll get back to the lighting. Let's make it more brighter this way. We have the shadows, but I wonder why they don't look that crisp at the moment. Maybe because I have the color rotated as well. Okay, let's continue. Next thing I want to add. So let geom equals new 3. Actually, icosahedron. Something of this sort. And then geom, and then get material. And then ball 1, get material. So now we have 2 balls of the same sort, and we can add them. Have the balls. They look beautiful. But now I want them to be rotating with the same surface. So I'm gonna do my own rotation. I think you could actually do the group and like add the wrapping object and then rotate it. But I'm just gonna do because I like taking sines and cosines. Well, I'm doing hyperbolic helicoid, which you already see on the screen. So then pole position x. And I also think I would need another one like this. Let me just mass sine theta c. And well, yeah, cosine. Now it's rotating. I think it's too big. All right, it's good enough now. And then we could I have two balls kind of falling from this surface in an attempt to get to the bottom, but never actually getting there. Which looks kind of beautiful. I'm wondering what have I messed up with my shadows? Why don't I have the crisp shadows? I should have had them. Maybe I missed something. Do I actually have shadow for the... Okay, I should also set the shadow part for the balls. Well, you could see the shadow of the balls, so it's actually working properly, but I'm wondering... just why. And where did we lose all the light reflection? I have my light, pretty good setup. Well, the ambient is just lighting everyone. Where was the ambient, by the way? Yeah, it was here. Well, I could, of course, make it less than that, but we still barely see the... So I think it must be something here. Maybe I should set some other parameters also. What was there in the material also? I think it was metallic. Maybe reflectivity, something. Oh yeah, I set this weird color, by the way. I'm not sure if it plays any role here. Oh, I don't think it's top down. I think it's going diagonally from the right. I mean, we could still see the shadow here of the balls. Kind of looks, well, it looks correct. I mean, it's just not that, well, crispy they wanted it to be. I mean, yeah. It shouldn't change anything, actually. Yeah. And I wonder where all the reflections went from my object. I think I should have had them. Well, I used to have them. So let's for a moment just comment this part. Well, it actually looks correct. Why is this the color? Let's maybe ambient. Well, I think this is it. This is what you get like with this kind of material, which you should play a bit more with the settings. It's not quite what I expected it to look, but it's real close. I wonder where all the reflections went. 200, 200. I think it's something with the shadow bias. Probably. Maybe I should change it. I should just remove it. Oh, I think it's better without it. Maybe I should make it even smaller than that. Well, yeah, I think it's much better now with this setting, and now I could get back to the my material. Yeah, I think it's much better this way. We still have shadow is not that like super crisp, but I didn't really want them to be super crisp. Well, this is the crisp enough to me. So I think we just did this amazing shader. There's also a lot of things that you could do with this one. Of course, you could look at different angles. You could rotate the balls just so you get an impression of them falling down. Yeah, sure, let's increase the directional light intensity. Get these weird artifacts, and I believe those are because of the shadow bias, right? Just change them. What could also be the reason for those artifacts? So if I just remove the shadow, maybe I just remove disable all the shadows, and let's see how it looks like. Yeah, there's no artifacts at all when we don't use shadows. Well, it's beautiful even with this look. It's actually, well, I don't really know how you would do these kind of reflections with three.js. There's a cube render target thing in three.js, but these reflections, you would see them in all the all the branches of the spiral. You would still see them, not only in this branch. You would see them on the bottom and on the top, all over the spiral. So I don't really know how you would do in three.js, just so you get the reflection just here, just on this part. It's kind of complicated. Maybe with a couple of renders you could achieve that, like some masking or something like that. So I really don't know how to do that. But well, I think we did close enough. So let's sum up what we did. We actually overrided the material, so it looks beautiful. It would be quite hard actually to implement all the parts, this material, to look as beautiful as it is in your own shader. And I think you gotta play with the bias a bit more. So maybe it's too big, too small. Yeah, you see like how much of a change it does. Yeah, probably, because with this kind of quality you just can't achieve it on the web without some hacking and some sort of this stuff. So yeah, this is the way you would achieve it. We could try to change the light position, just as President told us. Maybe it would change the look. So let's position it diagonally. You get different kind of shadowing here. I think without the bias it looks okayish. And you get those nice shadows, and depending on the angle that you look at it. Oh, it looks beautiful. Well, yeah, that may be also ray marching, but it's still kind of hard to do this look in ray marching, so I think it's most probably some software like Blender or something. Yeah, but still, well, at the core of that is just this formula, and I hope you just learned that you could, well, experiment a lot and just, you know, come with your own functions. But of course, this field is already like researched a lot, so you could just Google for some already existing beautiful surfaces and just implement them in three.js and just see like what beautiful things you could achieve with that, because Hyperbolic Helicoid is just one of them. But then, well, I just show you how you could build a sphere, a plane, or basically anything. And if you just change some parameters here, you would get some random beautiful stuff. So let's say I want a torsion to be not 5 but 10. Well, of course it would break the balls, but we will get a lot more torsion, I guess. But then if we just set it to something like 1, you'd get this kind of surface, which is, well, for me even more beautiful because it's so smooth and, well, it's just beautiful. And with this, actually, the reflections might work with this one because we only have one side of this one and the balls are on the same position, same opposite position. So this might work with the reflection because there is a three.js cube render target thing with the dynamic cube maps, and you could do those reflections. So with this surface, you could actually implement those, and this might look beautiful. So let's play a bit more with the parameters. So I just what have I done? I just changed the torsion, but then, well, let's set it to 3, and then let's multiply, like this alpha with 5. Just randomly multiplying something. Well, okay, this went off the charts. So let's multiply this one with 2. And you would get something like this, which is also cool. So it's not really a surface anymore, it's like something you put on a Christmas tree. Right. And then, well, let's divide this one by 3. I'm just really randomly multiplying stuff, never really did this. Okay, this is just makes it longer. So let's multiply this one by 0.1. Okay, this just makes it bigger on the other proportions. So let's maybe then, what do we do here? What if we do the t dependent from the actual u? What's gonna happen? Oh, this is some alien stuff. And dependent on v. So we have the torsion changed from top to bottom. So at the bottom the torsion is actually 0, and at the top it goes all over to 3. But we could make it actually 30. So you could get kind of this thing, which is, well, I don't know what it is, honestly. But probably you could just put those into the Blender, render them, and it's gonna be, well, real beautiful. So let's bring it back to 4. And then what else could we do here? So just at the beginning where we messed up the hyperbolic cosine and the sine, we could as well just replace one of the hyperbolic sines with cosine. And, well, it gets weird. Even more weird than that. Now what the hell is that? Suddenly it's not connecting in the center, but you get this coolish stripe. What if I just replace it with theta? Well, it's up to your creativity, probably. You could do anything with this. It's just exploration. This is what probably generative art might be, just exploring things, just setting up some rules, which are, in this case, the rules are just the parametric formula, and then you play with that formula until you get something that nobody ever got, and then you're just happy. Alright guys, that's it. We're over an hour. I think this should be good for our first stream to kick it off. I have no idea what is that. This is something inspired by the Hyperbolic Helicoid. But yeah, let's bring back the ribbon. Yeah, pretty cool. I could actually change the torsion to... You would get something like this. Well, I think it's overlapping itself, so you gotta be careful with those parameters, because at the moment you could see that those glitches, but it's still a beautiful thing, right? And it's hyperbolic, so when it rotates, you just get this feeling that it just grows. Not gross, but grows. Hey, thank you guys. Hope you liked the first stream of the year. And I will see you in the next ones. And let me know in the comments, and well, just help me to promote those videos. Just like and comment, this really helps for my videos. And well, if you want, you can support me on Patreon. Sometimes I post some stuff on Patreon, sometimes I post some stuff on Discord channel. That's it. Hope you liked last year, hope you're gonna like this new year. A lot of stuff coming in this year, and happy new year to everyone, and happy old new year. Yeah, because the old new year is coming this Thursday, so happy upcoming old new year to everyone. I don't know if you know about this one, probably all the Russians know, and the Ukrainians. Well, Chuck Norris just told me that I'm cool, so I think I need to drink something. So guys, see you in the next one. I will announce it on Twitter. Maybe it's gonna be next Sunday, but maybe not the next one.